Chang'e 4 rover comes into view on January 30, 2019. Lunar Reconnaissance Orbiter Camera (LROC) acquired a spectacular limb shot centered on the Chang'e 4 landing site, looking across the floor of von Karman crater. At the time, the Lunar Reconnaissance Orbiter (LRO) was more than 200 kilometers from the landing site, so Chang'e 4 was only a few pixels across and the rover was not discernible. The following day LRO was closer to the site and again slewed 59 degrees this time to capture another view. This time the small U-22 rover shows up 2 pixels just north of the lander. Also, shadows cast by the lander and rover are now visible. At some time after the formation of von Karman crater, the crater floor was covered by eruptions of basaltic lava, similar to the eruptions in Hawaii last summer. Chang'e 4 will collect compositional measurements of these farside basaltic rocks, and lunar scientists are anxiously awaiting these results. Do volcanic rocks on the far side differ from the basalts collected from the near side? We will have to wait and see. A striking aspect of the floor of von Karman crater is the number and variety of impact craters. There is a high density of craters because the surface is more than 3 billion years old. During those 3 billion years, so many small craters less than 200 meters (660 feet) in diameter formed that when a new one forms, the total number of craters does not increase. This seemingly counterintuitive situation occurs because each new crater erases, on average, one older crater of comparable size, a state known as equilibrium to crater-counting geologists. For surfaces this old in equilibrium, only larger craters greater than 1,000 meters (3,280 feet) diameter, which are not in equilibrium, continue to increase in density and can be used to estimate the age of the surface. Note also all of the small craters that have formed on top of larger ones. Smaller impacts wear down and degrade larger craters over time. You can easily see a wide variety of crater degradation states, ranging from sharp and crisp new to highly degraded old. As a result of all of these impacts, small and large, the surface of the Moon consists of a very fine powder known as regolith, in which the Apollo astronauts made their distinct boot prints. LROC is a system of 3 cameras mounted on LRO that capture high-resolution photos of the lunar surface. Getting a glimpse inside the Moon. New research from University of Alberta physicists provides the first-ever model of our Moon's rotational dynamics, taking into consideration its solid inner core. Their model helps to explain why, as seen from Earth, the Moon appears to wobble on its axis. The answer, said physicist Matthew Dumberry, lies in the complex geometry of the Moon's orbit, locked in what is known as a Cassini state. The Moon goes around the Earth, but its orbit is inclined by about 5 degrees with respect to the normal to the ecliptic plane, the plane about which Earth rotates around the Sun. But just like the Earth's rotation axis is inclined by 23.5 degrees in space, the Moon's rotation axis is also inclined by about 1.5 degrees, explained Dumberry, associate professor in the Department of Physics. Over one orbit, it points at the same direction in space, which is in the same plane as the normal to the orbit of the Moon. This defines a Cassini state. This type of lunar orbit was first observed by Giovanni Cassini more than 4 centuries ago. Since that time, the complex mathematical and physical elements of the Cassini state have been examined by scientists around the world. But what makes this model unique is accounting for a solid inner core at the center of the Moon. The heart of the matter. Essentially, we took all forces into account and tried to predict the angle of the inner core of the Moon, explained Dumberry. The tilt angle can be predicted, but we need to know accurately the deep interior structure on the Moon. However, we know it is not aligned with the mantle or the fluid core. We determined that the inner core is tilted as much as 17 degrees away from the mantle in one direction or 33 degrees away in the other. And, if scientists can identify the angle of the inner core, they will be able to develop a more accurate picture of the interior of the Moon. This is the first model of the rotational dynamics of the Moon that fully takes into account the presence of a solid inner core, said Christopher Stiss, graduate student who conducted this research under the supervision of Dumberry. Understanding the composition of the Moon's interior may provide insight to the events leading up to the formation of the Moon and the early history of the Earth. Earth's dust cloud satellites confirmed. A team of Hungarian astronomers and physicists may have confirmed two elusive clouds of dust, in semi-stable points just 400,000 kilometers from Earth. The clouds, first reported by and named for Polish astronomer Kazimierz Kordylewski in 1961, are exceptionally faint, so their existence is controversial. The new work appears in the journal Monthly Notices of the Royal Astronomical Society. The Earth-Moon system has 5 points of stability where gravitational forces maintain the relative position of objects located there. Two of these so-called Lagrange points, L4 and L5, form an equal-sided triangle with the Earth and Moon, and move around the Earth as the Moon moves along its orbit. L4 and L5 are not completely stable, as they are disturbed by the gravitational pull of the Sun. Nonetheless, they are thought to be locations where interplanetary dust might collect, at least temporarily. Kordylewski observed two nearby clusters of dust at L5 in 1961, with various reports since then, but their extreme faintness makes them difficult to detect and many scientists doubted their existence. In a paper earlier this year, the Hungarian team, led by Gabor Horváth of Eötvös Loránd University, modeled the Kordylewski clouds to assess how they form and how they might be detected. The researchers were interested in their appearance using polarizing filters, which transmit light with a particular direction of oscillation, similar to those found on some types of sunglasses. Scattered or reflected light is always more or less polarized, depending on the angle of scattering or reflection. They then set out to find the dust clouds. With a linearly polarizing filter system attached to a camera lens and CCD detector at Udítszlás Balog's private observatory in Hungary, Bátorszentendrei, the scientists took exposures of the purported location of the Kordylewski cloud at the L5 point. The images they obtained show polarized light reflected from dust, extending well outside the field of view of the camera lens. The observed pattern matches predictions made by the same group of researchers in an earlier paper and is consistent with the earliest observations of the Kordylewski clouds 6 decades ago. Horváth's group were able to rule out optical artifacts and other effects, meaning that the presence of the dust cloud is confirmed. Udítszlás Balog comments on their discovery. The Kordylewski clouds are two of the toughest objects to find, and though they are as close to Earth as the Moon, are largely overlooked by researchers in astronomy. It is intriguing to confirm that our planet has dusty pseudo-satellites in orbit alongside our lunar neighbor. Given their stability, the L4 and L5 points are seen as potential sites for orbiting space probes, and as transfer stations for missions exploring the wider solar system. There are also proposals to store pollutants at the 2 points. Future research will look at L4 and L5, and the associated Kordylewski clouds, to understand how stable they really are, and whether their dust presents any kind of threat to equipment and future astronauts alike. Lunar craters named in honor of Apollo 8. The newly named craters are visible in the foreground of the iconic Earthrise color photograph taken by astronaut William Anders. It depicts the moment that our shiny blue Earth came back into view as the spacecraft emerged out of the dark from behind the gray and barren Moon. This is arguably the most famous picture taken by Apollo 8. It became iconic and has been credited with starting the environmental movement. Since the Moon is tidally locked to the Earth, it always has the same side facing the Earth will never appear to rise above the surface to someone standing on the lunar far side. Orbiting around the Moon, however, gave the Apollo 8 astronauts, Frank Borman, James Lovell, and William Anders this stunning view, before they safely returned home to Earth. The Apollo 8 mission took place from 21 to the 27th of December 1968. After completing 10 orbits around the Moon on Christmas Eve, broadcasting images back to Earth and giving live television transmissions, the crew returned to Earth and landed in the Pacific Ocean. The Working Group for Planetary System Nomenclature (WGPSN) of the International Astronomical Union, who named the craters, is the authority responsible for the naming of planetary features in our solar system. The two named craters were previously designated by letters.